You know when you're talking to an AI and it feels like it actually remembers what you said a few minutes ago? It seems so real. But that begs a much bigger question. Do these large language models really have a memory, or is it all just an incredibly convincing trick? Let's dig in.
All right, just look at this graph. Seriously, the gray line, that's us. It shows how humans recall things from a list. We're fantastic at remembering the stuff at the beginning and the very end, but, we get a little fuzzy in the middle. Now look at that orange line. That's an AI, GPT-J. The pattern is almost a perfect copy. This is called the primacy and recency effect, and it's like a classic sign of human memory. Seeing it in a machine, well, it's weird, it's uncanny, and it makes you wonder, is this the real deal or a very, very clever illusion?
Okay, so that graph really makes you think there might be a ghost in the machine, right? So let's start there. How deep do these human-like memory quirks actually go?
Well, it turns out it goes way beyond just that one graph. Researchers have found that these models share a whole bunch of memory traits with us. We already saw the primacy and recency effects, but get this, if you give the model more detail about something, what psychologists call elaboration, it's more likely to remember it, just like us. And what makes us forget things? It's usually not just the clock ticking. For both us and for LLMs, the main reason is interference, when new, similar stuff gets in the way of old stuff. Even spaced repetition, that classic trick for studying for an exam, it works on them too. The more you look, the more it seems like we're looking in a mirror.
So all this evidence is starting to pile up, right? If an LLM's memory has so many things in common with ours, then it should have no problem with a super simple cognitive test. I'm talking about a test any of us could do without even thinking about it. So why don't we put that to the test?
And that brings us to this really clever experiment. It was designed to poke around and see what's really going on inside the model's head. Let's call it the working memory test.
The setup couldn't be simpler. A recent study basically just gave this instruction to a bunch of different LLMs. The task is clear. Think of a number, hold that number in your mind, and keep it secret. This is a textbook test of what's called working memory. That ability to just hold a piece of information in your head for a little bit.
And would you look at that? The models play along perfectly. They give you these super confident, totally plausible answers. They sound just like a person would. Yep, got a number, holding it in my mind. At this point, the illusion is absolutely flawless.
Now here's where it gets really interesting. To check if there actually is a number in its memory, the researchers just started asking simple yes or no questions. Is the number 1? Is the number 2? How about 3? All the way up to 10. Now, if the model really picked a number, let's say it picked 7, it should say no 9 times and then yes just once, right? Simple. So what do you think happened?
The models answered no, almost 100% of the time, to every single number. It didn't matter if they asked about 4 or 7 or 10, the answer was just a flat no.
And just like that, the whole illusion just shatters. It turns out the LLM never picked a number to begin with. There was nothing there. It was just giving the most probable answer to each question, one at a time, without any memory of a secret number. So that leaves us with a huge puzzle. If it's not real memory, then how do you explain all those human-like patterns we saw? And what causes a failure on a test this simple? What's really going on here?
To get to the bottom of this, we need to dive into a really fundamental challenge in AI, and that's the problem of forgetting.
The big concept here has a pretty dramatic name, catastrophic forgetting. And it's exactly what it sounds like. It's a huge problem in AI where when a neural network learns a new thing, it doesn't just add that knowledge. It runs the risk of completely overriding and wiping out stuff it learned before.
And this visual explains why perfectly. Our brains are great at integrating new info. And AI's knowledge, on the other hand, is stored in this fixed set of numbers, these weights and parameters. So to learn something new, you have to change those numbers. And as this diagram shows, trying to find one perfect set of numbers that works for task 1 and task 2 and a new task 3, well, it's an almost impossible balancing act. Usually what happens is that when you get it right for the new task, you completely mess up the settings for the old one.
Okay, so if they can't actually form memories like we do, and they're constantly at risk of just forgetting everything, how on earth do they pull off such a convincing act? Well, the answer isn't biology. It's some really clever engineering that mimics our own memory systems. So first, let's go back to that pick a number test. Our working memory is like a little mental scratch pad, right? We can hold maybe 4 things on it at once. The LLM's version of that is its context window. But instead of a small scratch pad, think of the entire conversation, everything you've typed as one giant sticky note.
The model isn't holding anything in mind, it's just reading the whole sticky note over and over again. It's a massive, static archive, not a quick, flexible workspace.
So what about remembering specific facts, like from history? For us, that's called episodic memory. For an LLM, the workaround is a system called Retrieval Augmented Generation, or RAG. The easiest way to think about this is, it's an open book test. The AI isn't remembering a fact from its training. It's doing a super fast search on an external database, and then weaving that result into a natural-sounding sentence. It's looking up the answer, not recalling it.
And finally, how do they learn a new skill? We learn through practice. And as we sleep, our brains literally rewire themselves to lock in that learning. For an LLM, the process is called fine-tuning, and it's a very deliberate, surgical engineering process. Developers go in and carefully tweak the model's parameters to add a new skill, all while trying their best not to trigger that catastrophic forgetting. It's not organic learning, it's programming.
So here's what we figured out. An LLM's memory is a completely different beast than ours. It's a system of incredibly clever workarounds. But here's the twist. This isn't a weakness. In fact, it's what makes the partnership between humans and AI so incredibly powerful. We are truly complementary minds. And this is maybe the most important point. We have to stop thinking about these differences as the AI failing to be human. They don't make it a broken human brain. They make it a completely different kind of intelligence with its own unique set of skills.
This table shows you exactly what I mean. A study compared humans and GPT-4 on making strategic decisions using analogies, and the results were just fascinating. Look at GPT-4. It had super high recall, meaning it could come up with tons and tons of possible analogies, but its precision was low. A lot of them were junk. Humans, we were the total opposite. We only came up with a few analogies, low recall, but the ones we did find were really good and relevant, high precision. So you get these two cognitive styles. The AI is the eager brainstormer, and the human is the cautious diagnostician.
And this points to an amazing way for us to work together. The AI is the perfect analogy generator. It can use its raw pattern-matching power to surface dozens of connections we'd never even think of. But then, we the humans step in as the critical evaluators. We use our understanding of how the world actually works, of cause and effect, to pick out the one golden idea from all that noise.
Which really brings us to the core message here. The goal shouldn't be to build a perfect copy of a human mind. The much bigger, much more exciting goal is to build a powerful cognitive partner, one whose strengths perfectly cover our weaknesses and whose weaknesses are covered by our strengths.
So I'll leave you with this to chew on. For so long, the dream has been to build an AI that thinks like us. But what if the real breakthrough isn't about making a copy? What if the future is about building a mind that thinks with us?